All right, thank you everyone for being here. I'm Francisco. I am one of the maintainers of OpenZeppelin contracts and associated projects. I've been in the company for several years now and working with contracts specifically. So I will be able to answer many of your questions. And today I'm going to share with you about access control and specifically about roles. But first, a little bit about the company. We've been working with multiple companies with the mission to protect this new open economy. With this goal, we have built a complete suite of security and reliability products and services that cover all aspects of a project in Ethereum, from development to operations. So specifically, we have the well-known OpenZeppelin contracts library that allows developers to build their contracts using our secure components. We also offer a security auditing service where we inspect the smart contract code and also other kinds of code and ensure that it works as intended by the developer. And more recently, we've released a Defender, OpenZeppelin Defender, a platform for automated operations for Ethereum projects. So everything from running admin actions on contracts on chain to monitoring your system, relaying transactions, and also documenting best practices around all of these topics. So OpenZeppelin contracts specifically, as I said, it's a smart contract library in Solidity, and it has a wide range of features. Most notably, there are implementations of token standards like ERC20 and ERC721, along with extensions to these standards. But there's also different security modules, utilities. Recently, we are working building some more governance contracts. And also a big part of it is an entire upgradability system with proxy contracts and also the upgrades plugins with automated security checks for everything around upgradability. But the other piece in OpenZeppelin contracts is the access control part. And this includes two modules, the Ownable module and the access control or roles module that we're going to be delving into today. So first, a little bit of a reminder about Ownable and the situations where it's useful and its different characteristics. So we're going to look at an example about an artist who wants to tokenize her work by publishing an NFT on chain and building NFTs for each of the pieces that she produces. So she's going to deploy this NFT contract with all of the usual NFT functions that allow to transfer, to trade, etc. But additionally, there's going to be a function to mint new tokens, and that's what's going to be used to mint these new pieces on chain as she produces. Because it can't be callable by anyone. It should only be callable by the artist herself as she wants to mint these on chain. So what she would do normally is make the contract ownable and protect the mint function with the only owner modifier. In this case, the owner would actually be herself. And this would be what allows her to mint the new NFT pieces as she produces them. Now, when you inherit the ownable contract, this introduces a number of functions into it. The first one is the owner function. This is a view function that returns the address of the owner, which is going to be the artist in this case. There's also the transfer ownership function that allows it to transfer to another account, and then the renounce function, which just does what it does. Now, we need to think now that we have an owner, there's going to be some security behind it. The owner, more specifically, is not going to be the person, of course, but going to be more likely a set of keys. And suppose that the artist deployed this NFT on an online platform using MetaMask or something like that. This is going to be a set of keys that are stored in her computer. So whenever we have this situation, we need to start asking ourselves, what are the risks involved? And this is something that we're going to have to do whenever there is this privilege keys in a system. We need to run an analysis of this to understand the situation and what we need to do exactly. So we will have to assess what will be the impact if these keys ever get compromised. Based on that, we need to design a key storage system, right? And there's going to be a set of trade-offs there, because the most secure key storage is just putting a key in a paper in a vault that you never access, but that's not a very useful key, right? So you're going to sit somewhere in between, the most secure and the most useful. So since there are going to be some trade-offs, you will also need to think about what mitigation measures you're going to put in place. So if a key is ever compromised, what is going to be the steps that you're going to take to recover from that situation? Now, all of this is very basic and happens whenever you have an owner in a system. But what's interesting for us today is that within a single contract, you can have many of these different analyses for different parts of the contract. So this takes us to what I like to call granular access control. So we're going to look at another example now, a little more complex and inspired in DeFi. So this is a stable coin that works by a series of incentives. And one of those incentives is some fee somewhere in the system. Now, this fee isn't automatic. It needs to be set in order to correct the system and bring it back to some stable point. And again, this is not automated. So the way that this is normally done, and the way it works, for example, on the MakerDAO system, is there is a DAO, what is called a decentralized autonomous organization, that is normally basically the community of token holders of, could be this very same coin, or more likely another governance coin, that are going to get together in this contract and make proposals and go through a voting process to vote whether these proposals pass or not. So in this case, there would be proposals to set the fee to something or to something else. Now, this contract also has something that is common, which is some emergency mechanism. In this case, it's an emergency shutdown that would, for example, wind down the system. And this would get triggered if, say, the underlying asset loses its value dramatically. Now, we can think here, if there is this emergency situation, maybe it is not ideal to go through the whole voting process, because it is really a slow process. You would need to make a proposal, you need to get together all of the token holders to vote for this proposal, and that's going to take a while. So there needs to be maybe an alternative. Now, a common alternative, this could depend on the stage of the project, but you could have a team multi-sig that can assess the situation, detect an emergency, and themselves trigger the emergency shutdown by not necessarily going through the DAO. You could even take it up a level further and introduce some more automation in there. You could write a smart contract that maybe detects if the price of the underlying asset has depreciated and automatically triggers this emergency shutdown. So we really have two different requirements here in the same contract. Now, does Ownable work for this situation? And it really doesn't work because, say, on one hand, we have different actors that need to have these privileges, and the owner is a single one. And on the other hand, these requirements change depending on the function that you're calling. So you can have the same owner for set fee and emergency shutdown. You would need to somehow tell them apart. So this is where we introduce the role concept. And for each of these functions, we're going to define a specific role. So for example, for the set fee function, we define the fee setter role. And in this system, it's only the DAO that has this role. But we can also define, say, the proposer role for the emergency shutdown, and it would be all of these actors that actually have this role. So how do we implement a system like this in code? Now, this is what the talk is about. The access control contract implements this role pattern. It is found in this import path, and it's used initially in a similar way to Ownable. You import it, and then you add it in the inheritance list of a contract. So for this stablecoin, it could look like this. You inherit ERC20, and then you inherit access control. So whenever you inherit access control, it, just like Ownable, adds its own interface to the contract. And this consists of some external public functions and some internal functions. Now, these are quite a lot. They are like twice the number that we saw in Ownable, but we're going to go now one by one and really understand what each of them means. So initially, we can look at has role. This is analogous to owner, but now there isn't a single owner, there is now multiple roles, and for each of them, there isn't a single account, but there are multiple accounts. So this is the API that we need to put in place. Now, what is this role argument here? Now, the way that we identify roles is through role IDs. And as we see here, it's just a number, a bytes 32 blob, which we recommend to set to the hash of a string describing the role. And the reason that we recommend this is simply so that it doesn't accidentally clash with some other role in the same system. And so once you define this role ID, you use it through the has role function to check that an account is allowed for a certain function. So you would see this line of code whenever you're using access control. Now, how do we get accounts into these roles? There isn't a single one like owners, so it's a little more complex. And there is two ways of doing this. The most simple one is this setup role function that we see here, an internal function that is really only meant to be called in the constructor. So by default, your roles will not have the deployer of a contract assigned to them. You would need to do that yourself using this setup role function by calling this line, for example, in your constructor. Now, this is one way to do it, which only works in the constructor, essentially. But the system also allows you to do this using external functions, which are grant for granting, like setup role, but then we also have revoke to revoke roles at some point. So we need to understand now who exactly is allowed to call these grant and revoke functions, because it's now a little different to owner. So let's go back to the DeFi example and try to reason through this and arrive at the solution. So we can ask ourselves here, how do we assign grant the responder role to new accounts? And we could maybe think, okay, let's make it ownable, and let's make it so that the owner is the one with the ability to grant new responders and grant new fee setters. But that's maybe not what we want, because we are building this because we're interested in the flexibility, and maybe we want to have different policies for granting new responders and granting new fee setters. So let's look at this as a drawing. Like we said before, we have these two roles, and we want to have the ability to grant them independently. So we can think that we will have like an owner for each of these roles that will be able to grant it and revoke it. Now, this is starting to look a little like roles themselves. So indeed, we are going to think that we are going to see these admins as other sets of roles that will not have the ability to set a fee or to trigger the emergency shutdown, but will have the ability to grant the fee setter role to accounts and revoke it and so on. Now, this is maybe not always what you want. You maybe want something a little bit simpler. And even if we think about the example that we just saw, you wouldn't have different admins for these two roles. It's likely just going to be the DAO, right? Administering these two roles. So maybe we also want the ability to have a single admin role for each of these. Right, so this is starting to tell us what we want the system, the roles system to look like. Now, a question arises here, which is, if admin is itself a role, then who is the admin of the admin? And this is a really interesting question, and you can devise different solutions depending on your particular circumstances. But one possible solution is to make the admin itself its own admin, right? One other solution would be to have this very special account that maybe you keep as a backup in cold storage, that it is the admin to the admin, and you never use it unless you are in some weird circumstance. So this is the system that's implemented in AccessControl. Every role that we have seen so far will have an admin, and that is seen in the interface to AccessControl in the getRoleAdmin function. It receives a role ID and it returns the role ID of the admin for that role. And it is the accounts in that role that will be able to grant it and revoke it. Okay, so now I know that you're probably thinking, oh, this is really complex. I'm going to have to set this all up. In reality, it is going to be a little simpler than that to start, because there is a sort of a default system set up that should be good enough for simple scenarios, or maybe most scenarios. And that default system is that every role that you create in your contract by creating this role ID will have a default admin that will be a global default admin for all of the new roles. Now, this role, the default admin, will not have any accounts in it to start. So that's something that you would need to assign in the constructor, right? Using the setup role function that we saw before. Now, this is just the default. You can customize it if you want to implement one of the systems that we just saw, for example, by using this setRoleAdmin function that is also in the interface to AccessControl. And again, one more detail here is that the default admin, it will be its own default admin. And you're going to have to think if this makes sense for you, if you are using the default admin. The reality is that we are still, the best practices around this are still being figured out. It's an ongoing conversation that we're having, and we want to invite you all to think about this for your own system and share your analysis with us. But my intuition right now is that it would make sense for the default admin to be its own admin and to make it a contract, like a multi-sig or something. I think that would make a lot of sense. But we're going to see concrete examples later. So the last function in the AccessControl interface is renounce role. That's just like renounce ownership. It allows an account to renounce its own role. And it's worth noting here that there is no way to transfer a role. It's just something that you need to keep in mind. And the reasoning behind this is that we think it provides more upfront clarity of what accounts will have a role and what accounts will be able to do what, and that it's only the admin for a role that decides what accounts have that role. Otherwise, the same role members would be distributing the role to others, and that wouldn't make a lot of sense. So this is the access control interface. To make it a little more concrete, we're going to now look at a concrete example. And this is an example from the OpenZeppelin contract library itself, the time lock controller. So first of all, let's see what a time lock controller is. A time lock controller is simply a contract that you deploy to the network, standalone, and which you can use to delay executing certain functions. So a common example about this is upgradability. You maybe have a system that is upgradable, but you don't want to feel like you are forcing upgrades onto your users. So you introduce a delay. You are going to propose an upgrade, schedule it for some time in the future, communicate it to your community, and based on seeing the upgrade and the changes that are going to be made, in this time period, the members and the users of the system are going to be able to exit the system if they don't agree with this upgrade, for example. So this is what the time lock controller achieves. The way that it works is you call a function to schedule a function in the time lock controller, and after time passes, it can be forwarded to the target. Now, since this is Ethereum, the contract can't just decide to forward it by itself. It needs someone to trigger that forward, in this case, by calling a function to execute that. Now, this is the system, and this is what it has to do. And we are implementing this using AccessControl. So now we begin to think, what roles do we need here? And we identified two roles. The first one is the proposer role. This is the role of accounts that will be able to schedule functions to be called. Like we said before, if you are going to be upgrading a system from this time lock, you don't want anyone to be able to schedule these upgrades. It's most likely going to be either the team multi-sig or some DAO or something like that. Now, additionally, we also can define the executor role of the accounts that will be able to execute. Since the delay has passed and the upgrade, for example, has already been delayed enough, you could think that executing can be open and that anyone could trigger execution, but it still makes sense to define a role just in case someone wants to have some finer control on the exact timing, right, of executing the function finally. So we have these two roles in the system that we've identified. And now we ask, who will be the admin of these roles? And it could be the default admin that we saw before, and we wouldn't have to do anything for that. But there's something a little more interesting that we can do in the case of the time lock. So what we do is we define a new admin role, the time lock admin role, that will be its own admin. Let's remember what this means. This means that accounts with the time lock admin role will be able to grant new proposers, right, and grant new executors. Okay, so they will have quite a bit of control over who calls these functions. Now, the interesting thing here is that we can make the time lock controller itself one of these admins. And what this means is that we can, some proposer can schedule a role grant, right? In this case, we want to schedule that we will grant the role of being a proposer to Bob, a new account. And then after the time passes, then what will happen is someone will execute this and the time lock controller will call itself using the grant role function. Now, as we saw, the time lock controller has the time lock admin role. And remember from the interface of AccessControl that this is the role that is needed to grant the role. In this case, the proposer role, because it's the time lock admin is the proposer's admin. So this just shows the kind of things that you can achieve. And this case is kind of like the time lock controller has its own protocol for administering its own roles. And the access control system allows you to put this in place. So let's see this in code. just to see how one would go about setting this up. So first, we define these 3 roles here, like I just showed you before, the constant with assigned to the hash of the same string for the time lock admin, the proposer role, and the executor role. So these just defines the role IDs. And now we need to set up the admin structure. As we said before, the time lock admin is its own admin. Remember, we do this calling set role admin. And the proposer's admin is the time lock admin, and the executor's admin is the time lock admin. So these 3 lines here set up the admin diagram that we saw before. And now we assign some initial members to the time lock admin role. And like we said, we assign the address this. This means that the time lock is its own admin. And we also assign the deployer account into the time lock admin. And this allows you to maybe run some tests on the time lock or manually assign proposers without having to go through the delay. And this is something that can be renounced later, right? Or it can be kept, or you can even grant another time lock admin as a multisig just to keep as a backup for safety. So this was the time lock controller, a rather complex system, but that shows the properties of access control quite well. Now, we're going to move on to a completely different example now. And we're going to do this using the help of the contracts wizard. We announced this week, actually. If you haven't seen that, you should make sure to follow us on Twitter to stay on top of the news. And what the contract wizard is a tool to interactively build contracts using the OpenZeppelin contracts components. So currently we only support ERC20s and ERC721s. And as you can see here, there's parameters and features that you can choose. What we're going to do now is try to implement the NFT system that we saw at the beginning. So just to show a little bit how this works, we can define some parameters here. In this case, they correspond to the constructor parameters, but there's other things that are not constructor parameters. And I think this is one of the cool things about the wizard is, for example, in OpenZeppelin 4.0, we changed the way that NFT token URIs are generated, and we made it cheaper and a little bit simpler. Now, you don't even need to know how that's implemented. You just come in here and fill in the form, and this does what it needs to do. So we think this is a really cool way to get started on the OpenZeppelin contracts. If you haven't seen, I invite you to play with it after this presentation. Not now, but you can also read the announcement for this that came out on Monday, if anyone wants to share it in the chat. But anyway, let's now try to implement the system from the beginning, the NFT. We see here in the features, one of them is mintable, and we can turn on mintable. And this makes the NFT ownable, because as we said, the mint function needs to be protected. And in this case, it's going to be protected using only owner. Now, this is the default, but in the access control section right here, you can change this over to use roles. And this is going to set up quite a bit of code and set up a simple system using access control, right? It changes the inheritance. It defines the minter role because it's the only feature that we selected, and it sets some initial accounts into these roles. So we have the default admin role, right? That we can see here, we didn't even have to define it. This is one of the roles that comes by default in access control. I'm sorry, it's the only role that comes by default, but we assign the contract deployer to this account. And we also assign the minter to this account. And this is just a default setup, but it's good enough to start working with this. And now what we can do once this is built is we can go here and copy it and paste it in our editor. We can open it in Remix, which is extremely cool. And we are all really excited about. And it's here, it compiles the green check mark should show up here at some point. But we can also download it. And anyway, you should go and play around with that a little bit. But this shows us now, again, an example of an NFT using AccessControl and a potential way in that we could organize these roles. So that's it for the examples. And I want to share just a little bit of what's coming next for AccessControl. We are focusing on improving sort of the client-side user experience, and that includes having revert reasons that hint at what role is missing. Currently, as you saw before, you need to write the require statement yourself, and this allows you to put in a custom revert reason like not a mentor or something like that. But we're going to automate this and using this only role modifier that is currently not there, but this is going to be there probably in the next release. Now, the cool thing about automating that is that it will enable interfaces such as OpenZeppelin Defender, shown here and at the right, to inspect these revert reasons and inform you, the user, what role you're missing to call whatever function you want to call. So these are one of the things that we are building now. Another very cool thing that Hadrian put together is the graph subgraph that indexes the blockchain for all of the standard access control events. And if you have your own scripts or your own UI that you need to monitor these roles and the way that they are granted or revoked and all of the admins, you can use the subgraph to do that very easily. So if you want to use this, you need to install the npm package or use the wizard. If you, for some reason, don't want to use the npm package, you can read the documentation here, ask all of your questions in the forum, and of course, try Defender, sign up for free over there. So thank you so much for paying attention to the presentation, and I will be hearing whatever questions you have now.